Okay. Now before I start really getting into the whole, hey, the decimal's in the divisor now scenario, I want you to look to the left at the golden numbers. Now the top problem we have, 35 divided by 7, is a pretty straightforward math fact, and we know, yay man, that's simple. There are 5 groups of 7 in 35. Now what if we took both the divisor and the dividend, oh, I went the wrong way on that, there we go, and we multiplied them by 10. We made them each 10 times greater. We'd end up with divisor of 70, dividend of 350. My question now is, how many groups of 70 are there in 350? Well, guess what? There are 5. 75 times 5 is 350. We end up with the same quotient because we've multiplied by 10. Now, if we multiplied by 100, as long as we did multiply both the divisor and the dividend by 100, we'd end up with the same quotient. Keep that in mind, because that's kind of the basis for how this whole dividing with the decimal thing ends up going. Okay? I wish I could move those, but they're not going. We're going to move forward. So if you look on the right, we have a problem where we have 63, and we want to group that into groups of 9/10. Now that could kind of mess with your head, but there's an easy workaround so that you end up with the correct quotient, but you don't have to have this headache of creating decimal size or fractional groups for no reason. And that is kind of what I just showed you. What I'm going to say is, let's multiply our divisor by a tens base number so that it no longer has a decimal in it. In this case, because we have 9/10, if we multiply that by 10, we get 9 whole. Here's the deal though. If I do that to the divisor, I must do that to the dividend. And 63 times 10 gets me 630. Why? So that we can end up back in a situation like we had with our whole numbers, where we have the same quotient, and don't end up accidentally thinking that we can just magically change 9/10 to 9 and do nothing with the dividend. It's not magic, it's math. From here, everything is pretty straightforward. We've seen this kind of problem many times. You can go with expanded notation. I'm going to go with old school, traditional shortcut this particular time. I cannot create groups of 9 out of 6, but out of 63, I can create 7 groups of 9. With nothing left over, I can bring that down, and I'm not going to have any ones in my quotient. It works, and that pesky decimal we don't have to worry about, but we end up with a quotient. So if we want to know how many groups of 9/10 are in 63, there are 70 groups of 9/10. But did it really work? Yeah. How do we know? Test it. Take a look. Okay. Oh no, it says 600. No, it doesn't. Remember, we got to do something with that decimal. So 63, 63. It absolutely works. Don't panic. Moving on. Let's say we're in the same situation here. This time, however, I noticed that my decimal divisor is a hundredths number, 71 hundredths. Well, I need to do some kind of multiplication so that my divisor doesn't have this weird decimal thing going on. Well, if this goes into the hundredths, I'm going to have to multiply by 100 to remove that decimal. 71 hundredths times 100 leaves me with 71 as my divisor. I'm not done. Because if I'm now suddenly using a divisor that's 100 times more than my original, then I have to have a dividend that's 100 times more than my original. And of course, if I multiply by 100, then I can figure that out any way I want, or I can just kind of know, oh, 100, 2 zeros, gonna stick them on. And then the weird thing, of course, here is you end up with this ginormous number. Don't worry, it's actually not gonna shake out to be a difficult number to divide. Again, we'll go ahead and we'll give it some shortcut love. We'll start by thinking, well, I don't know my 71s, but because I know my 7s, I do know my 70s. And I can't get any groups of 70 out of 1 or 11, but I can out of 113. So my first digit is going to be here above this 3 in the thousands place. And I'm thinking to myself, 7... 14, 21, 7s can go, I can probably go to my 9s, or what am I talking about? I can't go, 70, 140, I think I'm only going to be able to do 1, because 71 times 2, it's 142, yeah. I got a little lost there, but I'm back on track. I can't do more than one group of 71 here. And that leaves me with 42, but of course I'm going to bring down the next digit and work in the hundreds place. Now from here, I know I have 70, 426. I know that 7 times 6 is 42, so I want to try 71 times 6, because I think, haha, 426, that absolutely is going to be the best I can possibly do, because then I've grouped everything here. Now when I bring down this next 0, I have nothing for the tens place in my quotient. Bring down this 0 in the ones place, again, there's nothing to divide out, so I end up with a quotient of 1,600. Again, I can look at that and say, well, how can I know I got that right? Well, if you multiplied things here at the start correctly, we should just be able to check this pretty quickly. I have my, whoops, where's my comma? There we go. I have my quotient, and I can multiply that by my original, if I want, divisor, and that should make it relatively simple for me. And remember, 2 places over here means 2 places over here to check, and it checks mathematically correct. So even though this whole, but I multiplied by 10 or I multiplied by 100 thing can seem kind of crazy, it works as long as you remember, if you multiply that decimal out of the divisor by 10 or by 100, you must multiply by the same number in the dividend. Otherwise, you're going to end up with magic instead of math. Good luck.